In this video, we will learn how to determine the empirical formula of a hydrate. The goals of this video are to briefly introduce you to chemical formulas, learn how to understand empirical formulas, and learn how to determine the formula of a hydrate. A chemical formula is a way to represent the amount of different atoms that make up a single molecule. For example, I'm sure we all know that H2O represents water and NaCl represents table salt. By using these formulas, we know that in water there is hydrogen and oxygen, and in table salt there is sodium and chloride. There are two different types of chemical formulas that we will cover in this video: molecular formulas and empirical formulas. You're most likely familiar with molecular formulas, which denote exactly how many atoms there are in a given molecule. For example, here we have ethane, which looks something like this. We can see that its molecular formula would be C2H6, since there are 2 carbons and 6 hydrogens. Empirical formulas are a little different. Instead of showing the number of atoms, empirical formulas represent the ratio of atoms in a molecule. For example, here we have propene. While its molecular formula would be C3H6, since there are 3 carbons and 6 hydrogens, its empirical formula would only be CH2, because there is a 1:2 ratio between the number of carbons and the number of hydrogens. It is important to know that different molecules can have the same empirical formula. For example, ethylene, whose chemical formula is C2H4, also has the empirical formula CH2, since again there is a 1:2 ratio between the number of carbons and the number of hydrogen atoms. A hydrate is a compound in which water molecules are part of the crystalline structure. For example, copper 2 sulfate pentahydrate has 5 water molecules for each 1 copper 2 sulfate molecule. When a hydrate is heated, water will break away from the overall crystalline structure, and the anhydrous solid will dissolve in the water. If we know the mass of the hydrated sample, and we know the mass of the sample after heating, we can determine the formula of the hydrate. In the next example, we will ask the questions: what is the mass of the water held in the compound? How many moles are there? And what is the chemical formula of the hydrate? Determining the formula of a hydrate. Let's take the example of calcium chloride hydrate. Now, we don't know how many molecules of water there are for each calcium chloride, but if we know the mass of the hydrate and the mass of the final dried product, we can know the mass of the water, since that is all that is lost in the heating process. For this example, let's say that there were 147.1 grams of hydrate, and there was 111.1 grams of final solid product. That means that we are left with 36 grams of water that must have been a part of the original molecule. Since we know the mass of the water and the mass of the dried calcium chloride, we can find the moles of the water and dried calcium chloride. The number of moles would be equal to the mass of the sample divided by its molar mass. For our example, in the case of water, this would be 36 grams divided by 18 grams per mole. As you can see, grams cancel out, and that leaves us with 2 moles of water. For the dried calcium chloride, this would be 111.1 grams divided by its molar mass, which is 111.1 grams per mole. Again, grams cancel, which leaves us with exactly 1 mole of calcium chloride. From here, the formula of the hydrate can be determined by dividing the moles of water by the moles of the solid product. So, 2 moles of water divided by 1 mole of calcium chloride, which clearly leaves us with 2. That means our chemical formula is CaCl2 2H2O. Reflect on your answers to these questions and provide them in your reflection at the end of this module. Remember, if you have any questions, please ask them on the Course Piazza site or reach out to your TA to ask.